Today we shall discuss a typical problem on continuity and differentiability. So let us take a problem. Let A be a function from set of real numbers to real numbers, that is R to R, and G is another function from R to R. With two functions satisfying the conditions f of x plus y equal to fx plus fy plus fx into fy and fx is equal to x into gx for all xy belongs to R. Also it is given that limit gx x tends to 0 equals to 1. Then which of the following statement or statements are true? Number 1, f is differentiable at every x belongs to R. Number 2 is if g0 equal to 1, then g is differentiable for every x belongs to R. And number 3 is that derivative f dash 1 equals to f dash 1 equals to 1. And number 4 is f dash 0 is equal to 1. Which of these following statement or statements are true? So first of all, it is given that fx is equal to x into gx. So if we take limit both sides as x tends to 0, what do you get? Limit x tends to 0 of fx is equal to limit x tends to 0 x into gx. We can write this as the product of the two limits, limit x tends to 0 of x into limit x tends to 0 dx, and this is given as limit x tends to 0 dx equal to 1, 0 into 1, and this is equal to 0. Also it is given f of x plus y equals to fx plus fy plus fx into fy. In this relation, let us put x equal to y equals to 0. So what do you get? F of 0 plus 0 equals to f0 plus f0 plus f0 whole square, and this implies f0 whole square plus f0 equals to 0. This is equation number 1. Now let us check the continuity of the function fx at any point x equal to a where x belongs to R. So limit h tends to 0 f of a plus h. What do you get? By our given condition, we can write this as limit h tends to 0 fa plus fh plus fa into fh. Now if we take the separate limits, this is our constant fa plus limit h tends to 0 fh plus fa into limit h tends to 0 fh. So we can write this is equal to fa plus 0 and this is equal to fa. Similarly, we can write limit h tends to 0 f of a minus h equal to fa. So we can say that fx is continuous for all x belongs to R. So f0 is equal to as because it is continuous for all x belongs to R. So f0 equal to limit x tends to 0 of fx, and that is equal to 0. Now, after that, we check the differentiability of the function at x equal to a. We know that f dash a plus h equal to limit h tends to 0 f of a plus h minus fa this upon h. This is equal to limit h tends to 0. By our given condition, we can write f of a plus h is equal to fa plus fh plus fa into fh, then minus fa to this one. So this cancels fa and fa. So we can write this as fa plus 1 into limit h tends to 0 fh by h. So this is equal to f of a plus 1 into limit h tends to 0 h into dh by h, as because you are given that fh is equal to h into dh. So we can write fa plus 1 into limit h tends to 0 of dh, that is equal to fa plus 1. So we have got f dash a plus h equal to fa plus 1. Similarly, we can write f dash a minus h is equal to fa plus 1. So fx is differentiable at x equal to a, and hence it is differentiable for all x belongs to R. As because we have taken any point x equal to a belongs to R, so we can say that the function is differentiable for all x belongs to R. Now what we have got? We have got f dash x is equal to fx plus 1. So we can write this as f dash x by fx plus 1 is equal to dx. Now if we integrate both sides with respect to x, what we get? Integration of f dash x dx by fx plus 1 equal to integration of dx. So this is nothing but log of 1 plus fx is equal to x plus c. Now we have to find the value of the constant of integration. We are given the x equal to 0, f dash 0 equal to 0. So put here log 1 equal to c, so c equals to 0. Now put here therefore log 1 plus fx is equal to x. So we can write 1 plus fx is equal to e to the power x. This implies fx is equal to e to the power x minus 1. Then you differentiate both sides with respect to x. So f dash x is equal to e to the power 0. So we can write f dash 0 equal to e to the power 0 equals to 1. So if 0 equal to 1, then what is our gx? Gx is equal to fx by x. That is of e to the power x minus 1 by x when x not equal to 0, and this is equal to 1 when x equal to 0. So clearly limit x tends to 0 of dx, that is of z0 equals to 1, and so dx is continuous as because limit dx as x tends to 0 equal to g0 equals to 1, so dx is continuous at the point x equals to 0. Since fx is differentiable, then you can say that fx by x is also differentiable. So gx is also differentiable. When it is differentiable? When g0 equal to 1. So finally you have got that the options A, B and D are correct. So first one is A, then B is correct, and finally D is also correct. Thank you.